Welcome to The Explainer. Today, we're going to unpack one of the most fascinating, double-layered mysteries in human evolutionary biology. Have you ever actually stopped to think about how weird our bodies are compared to the rest of the animal kingdom? We are looking at the dual paradox of human hair. Basically, why we lost almost all of it, and why, against all evolutionary logic, we kept it in some very specific, highly visible places.
Okay, let's dive into this. Seriously, just look at our closest relatives in the animal kingdom. Chimpanzees, gorillas, orangutans, they're all covered in dense, protective fur. Humans stand entirely alone as the only naked primate. It's a glaring biological anomaly. I mean, we're mammals, right? And fur is essentially the defining characteristic of being a mammal. So why on earth did our lineage decide to just shed its primary source of protection and insulation?
To really get how strange this is, we have to look back, way back. Around 165 million years ago, ancient mammalian relatives, like the squirrel-like Megaconus, relied on a thick coat of fur for thermal insulation. That fur trapped air against the skin and blocked out the sun. Now contrast that with a modern human. We're completely bare-skinned, totally exposed to the elements, and frankly, we are unusually sweaty. It's a drastic, totally unusual shift away from millions of years of mammalian design.
So how did we actually get here? The story of our denudation really begins about 6 million years ago when we diverged from chimpanzees, but the crucial shift happened around 2 million years ago with the emergence of Homo erectus. We committed to walking upright on two legs and moved out onto the hot, open African savanna. We started hunting using something called persistence hunting, which literally means chasing prey for hours until it just collapses from heat exhaustion. But to do that without dying of heat stroke ourselves, we needed a radical new cooling system. By 1.2 million years ago, a mutation in the MC1R gene shows that early humans had developed dark UV protective skin, which is the smoking gun proving that our insulating fur coats were officially gone.
To replace that fur, our bodies developed an astonishing number of eccrine sweat glands. We have anywhere from 2 million to 5 million of these tiny glands covering our skin. Just to put that into perspective for a second, that is 10 times more sweat glands than a chimpanzee. We literally swapped our fur coat for a highly advanced, water-based thermoregulatory system.
And this system is incredibly powerful. Under extreme conditions, a human can pump out up to 3.7 liters of sweat in a single hour. Yeah, it's a little gross to think about, but this was our absolute evolutionary superpower. Because we had microscopic, fine vellus hairs instead of thick fur, that sweat could evaporate directly off the skin, instantly cooling our blood and protecting our large, vulnerable brains from overheating while we chased down prey.
But here is a truly wild fact. We didn't actually lose the genes to grow fur. Genomic screens show we still have the complete genetic blueprint to be entirely covered in thick hair, just like a chimp. Instead, evolution just gave us a genetic switch. Our bodies produce regulatory inhibitor proteins, most notably one called DKK2. You can think of this protein as a biological roadblock on the WNT signaling pathway. It essentially cuts off the communication that tells hair to grow, forcing the hair follicles across our bodies to stay quiet, which effectively turns off terminal hair growth.
So the crucial point is, why wasn't the head completely denuded like the rest of the body? Well, because we were walking upright on the equator, the top of our head was taking the direct, punishing brunt of the midday sun. Scalp hair was spared to insulate our large brains from that solar radiation. Tightly curled hair evolved as a highly specialized adaptation to maximize heat dissemination and block radiation. Actually, it wasn't until humans migrated out of Africa into cooler climates that straight hair evolved, which reverses things and enhances heat gain to keep the head warm.
But just when you think you understand human evolution, it throws a massive contradiction at you. I call this the Great Beard Paradox. If our entire evolutionary journey over millions of years was driven by the need to lose fur so we could cool down, why on earth did human males retain the ability to grow thick, dense, highly insulating fur right on the lower half of their faces? It completely defies the thermoregulatory logic we just established.
To solve this paradox, we really have to look at the chemical culprit at the center of this biological mystery, dihydrotestosterone, or DHT. DHT is a highly potent metabolite. Basically, think of it as a supercharged version of testosterone. Your body takes circulating testosterone and uses an enzyme called 5-alpha reductase to convert it into DHT. And this specific hormone is the absolute primary driver of how your hair follicles behave.
But here's where the body plays a pretty cruel trick. If you're genetically susceptible, DHT does two completely opposite things. On the top of your head, DHT triggers signaling molecules that restrict blood flow and cause premature cellular senescence. It literally shrinks the follicle in a process called miniaturization, which leads to baldness. But on the face, that exact same DHT hormone acts as a powerful fertilizer. It stimulates growth factors that cause cellular hypertrophy, turning fine, invisible hairs into thick, coarse beard hairs. So if you've ever wondered why some guys lose the hair on top of their head but can grow a massive lumberjack beard, this cruel biological trick is exactly why.
And this brilliantly illustrates that the secret here isn't just about testosterone. It's about localized epigenetic programming in a tiny structure at the base of the hair called the dermal papilla. You can think of the dermal papilla as the soil the hair grows in. The papilla on your scalp is programmed to self-destruct when exposed to DHT, while the one on your jawline is programmed to thrive and multiply under that exact same hormonal signal.
Because the beard lacks a direct survival benefit for the whole species, women and children survive perfectly well without them, evolutionary biologists believe it was actively preserved by sexual selection. The experts point to 4 main drivers: dominating other males, attracting females, proving your immune system is top-notch, and literally acting as physical armor. Let's break these down real quick.
First up, let's look at what anthropologists call the masculinity paradox. Highly masculine bone structures, like a heavy brow and a huge square jaw, signal health and strength, right? But they can also signal antisocial traits, aggression, and low empathy. Beards act as a visual buffer. They soften those overly aggressive bone structures, signaling maturity, approachability, and the potential for long-term resource provisioning to mates, all without losing that underlying appearance of formidability.
Then we have the immunological side, where we see 2 totally opposing theories based on discussed sensitivity. The ectoparasite avoidance theory suggests that because beards can harbor bugs, ticks, and bacteria, they really should be a major turnoff in environments with high disease rates. But the parasite stress theory argues the exact opposite. Because high testosterone actually suppresses the immune system, growing a massive thick beard is biologically costly. So if you can grow one and not get sick, it serves as an honest visual certificate of your superior genetic health.
But perhaps the most action-packed theory is the pugilism hypothesis. This is the idea that the beard evolved not just for looks, but for actual physical combat. Early humans engaged in a lot of hand-to-hand, male-on-male violence, often targeting the face and jaw. So could the beard have evolved as a built-in shock absorber?
Now, what's really interesting about this slide is how researchers at the University of Utah actually tested this wild theory. They created bone-like epoxy models, covered them in sheepskin to simulate human tissue, and hit them with a blunt force impactor. When the skin was fully furred, the bone failed only 45% of the time, but when they sheared it down or plucked it completely bare, the failure rate spiked to 95 and 100%. The springy keratin fibers of the hair actually absorb and distribute the kinetic energy of a punch, genuinely protecting the fragile jawbone underneath.
So biology clearly gave us the beard, but culture dictates when we actually wear it, and that's driven by a concept called negative frequency dependent selection, or NFDS. This is an evolutionary mechanism where a trait is highly attractive when it's rare, but the moment it becomes too common in a population, it completely loses its appeal. Think of the modern hipster beard trend. When just a few guys had them, they stood out. When literally every guy in the coffee shop had one, the clean-shaven look suddenly became the premium choice again.
Let's move to and see how this builds in historical fashion. If we look at British facial hair trends, we see NFDS perfectly in action. In 1853, sideburns peaked. By 1877, it was all about the mustache and sideburn combo. In 1892, full beards utterly dominated society. But by World War I, the isolated mustache took over. These aren't just random fashion choices, guys. This is evolutionary biology and sexual selection playing out in real time, oscillating back and forth as different traits lose their rarity. From shedding our fur to survive the brutal heat of the savanna, to retaining our beards to signal dominance and survive a punch to the jaw, our hair is a living, growing record of our evolutionary past. But it leaves us with a pretty fascinating question. As modern culture, climate control, and technology completely shield us from the elements and physical combat, what selective pressures even remain? How will human hair evolve next? Will we eventually just lose the beard entirely, or will culture keep it alive forever? Keep that in mind the next time you look in the mirror. Thanks for joining me on this explainer, and keep learning.